Chapter 11, Part 2. Frederick explained that their bodies could be like robots that borrowed from the awareness of the vacuum. He had to explain that in quantum mechanics, even empty space was not truly empty. It was filled with virtual particles that constantly popped in and out of existence for fleeting moments, governed by Heisenberg's uncertainty principle. These were known as the quantum fluctuations or vacuum fluctuations, which gave rise to awareness. The static Casimir effect demonstrated that these fluctuations could have measurable consequences. If one were to place two uncharged, parallel conducting plates very close together in a vacuum, a small attractive force arose between them. This was because the presence of the plates restricted the possible wavelengths of virtual photons between them, leading to a lower density of virtual particles and thus a lower energy density inside the plates compared to outside. The resulting pressure difference pushed the plates together. Moreover, the dynamical Casimir effect took this concept a step further. Instead of static boundaries, they should imagine boundaries that are vibrating or oscillating very rapidly. If these changes occurred at a speed comparable to the speed of light for the virtual photons, they could shake these virtual particles hard enough to convert them into real, observable photons. In essence, the energy from the rapid motion or change in properties was pumped into the vacuum, causing the virtual particles to become real. The dynamical Casimir effect was a physically realizable non-unitary process that acted on the local vacuum. However, the effect only extracted a finite small amount of energy and created a specific, limited type of excitation which influence on the global vacuum was negligible. The effect did not suffice in creating the arbitrary states required by the full mathematical scope of the Riche-Leader theorem. He explained that a highly speculative, though intriguing, theory of consciousness posited that consciousness arose from quantum processes within cylindrical microtubules inside neurons, rather than solely from synaptic firing. A key aspect of the theory involved quantum vibrations within these microtubules. Some theorists suggested that microtubules exhibited or could exhibit coherent quantum vibrations across a vast range of frequencies. Some studies had modeled these oscillations at around 613 terahertz, which fell into the visible light spectrum, specifically blue light. If one were to hypothetically assume that these proposed terahertz microtubule vibrations could act as the moving boundary or rapidly changing boundary for a dynamical Casimir effect within the microtubule's structure or its immediate environment, then the photons theoretically produced would be at frequencies related to these very high internal oscillation frequencies. Following the principle where the emitted photon frequency is half of the vibrational frequency, then if the microtubules vibrates at terahertz frequencies, the emitted photons could also be in the terahertz range, which would lead to infrared or even visible light. If photons were generated, they would be actual electromagnetic radiation. The idea of consciousness as light in this context would mean their local awareness was the amplified quantum fluctuations. He explained that the microtubules could generate the dynamical Casimir effect through vibrations. Then the neuron would need to be equipped with sensitive detectors with a setting sigma which had orthonormal columns. The neuron would collect local current fluctuations from polarization created by the dynamical Casimir effect. Then the detector would need to be able to calibrate itself in order to convert the current samplings into mixed quadratures, Q. Then the neuron would be able to separate the measurements into hyperbins and thereby calculating a probability density P. Then, to find the quadratures, they projected R equals sigma Q, which could be done since sigma had orthonormal columns. If they assumed the state was centered, meaning Langle R angle equals 0, then the diagonalization of the covariance matrix gamma could be found by a neural net using Sanger's rule with input equals R. The diagonalization was needed in order to find S mathem real equals SQRT2 gamma, which was symplectic if gamma was assumed to be pure. From S mathem real, the neuron could find S by rearranging. And then the kernel K equals .SS-1 could be found, and since S was a Bogolyubov transformation, its inverse could be easily found by rearranging its entries with no calculation needed. K could then be used to find the mode frequencies omega K since K11, mathem diag, equals I operator name diag, omega 1, omega n. Before the kth neuron passed on information to the next neuron, it calculated from the previous number of inputs, theta I, tau I, which had been received from the previous number of neurons. It deleted sufficiently old data. Then it made sure that omega k was within the range. Begin equation. Nu rk lek omega k lek nu plus rk. End equation. Where nu is received by the previous neuron. By ensuring the inequality, the neuron found itself phase locking with the local neural net, as it was modeled as a Kuramoto oscillator. Now the neuron could measure the electric permittivity epsilon k in the membrane with quantum tomography of the vibrating microtubules' dynamical Casimir effect that were just outside the membrane through interaction with a light-sensitive molecule called retinal, which was bound to a protein called opsin. Opsin 5 was found in mammalian brain neurons and was sensitive to violet light, which fell in the range of the vibrating microtubules' dynamical Casimir effect. This was because just inside the membrane, there was a ladder of actin rings spaced about 180 nm apart. Microtubules often ran parallel to these rings, occasionally dipping close to the surface to deliver cargo to the membrane. Since quantum tomography measures the speed of light in the medium, the neuron could only deduce epsilon k by the fact that there was little to none magnetic field in the brain, so the dielectric permittivity mu was effectively the same as its value in vacuum, a constant. The neuron had information about its membrane thickness, axon radius, and axon length Lk. The temperature was measured in the membrane by transient receptor potential channels that act as molecular thermostats. It then calculated the time taken for a single signal to pass through itself and added it to the elapsed time received from the previous neuron. If the total elapsed time reached a certain threshold, then it just passed on its internal signal time. In this case, the neuron passed on theta k, otherwise it passed the phase given by the previous neuron. The neuron then calculated the exponential moving average. Begin equation. Nu n plus 1, 1 alpha nu n's. End equation. With alpha equals frac 2m plus 1 for effectively weighting the past m neurons' frequencies to the moving average. It passes the new frequency on to the next neuron along with the other data. Frederick went on to say that in the framework where epistrophy, the reflective alignment of a hypostasis, increased the effective value of h-bar in local microtubule cavities, the dynamical Casimir effect fields generated by time-dependent boundary conditions became stronger in absolute amplitude. This effective increase could either happen from an increase in the cavity size velocity .L, or it could be a literal increase in h-bar. While the intrinsic quantum state of the field remained a pure Gaussian, the increased effective h-bar amplified the energy per photon and the zero-point fluctuations, making the dynamical Casimir effect radiation more prominent relative to classical and thermal noise in the environment. This was because that an increase in the effective h-bar did not increase thermal noise, but only the dynamical Casimir effect radiation intensity. In effect, this amplification effectively raised the signal-to-noise ratio, so that the coherent oscillations and correlations of the dynamical Casimir effect radiation stood out more clearly against decohering influences. As a result, although the field's intrinsic quantum purity was unchanged, the detectable signal appeared more coherent and ordered, allowing the microtubule network, and by extension the neurons they inhabit, to manifest a more synchronized, macroscopic pattern of electromagnetic activity. In this way, epistrophy increased local effective h-bar, which enhanced the functional coherence of the field of awareness, effectively converting quantum potential into detectable, organized patterns that served as the substrate for locally manifested awareness. In that way, epsilon in the membrane could be measured more accurately, leading to a more accurate R, which ensured that the inequality held. Frederick explained that microtubules, which was sensitive to electromagnetic field variations and cavity-like boundary conditions, now experienced this enhanced dynamical Casimir effect field as a biasing influence. The quantum fluctuations did not determine their behavior, but they introduced slight, structured asymmetries in conformational dynamics, dipole orientations, and charge migration. Because the dynamical Casimir effect signal was more prominent, these microscopic biases were more coherent across space and time. This created microstructural order, tiny, synchronized tendencies within microtubule networks that would otherwise be washed away by noise. Neurons operated in a regime where small biases could be magnified. When microtubules within a neuron shared correlated fluctuation patterns, they subtly shaped ionic currents, firing thresholds, and membrane excitability. A consistent quantum-derived microstructural bias, therefore, entrained local neural firing rhythms, nudging them toward shared oscillatory modes. Nearby neurons began to synchronize because they were all being influenced by a common, structured subneural signal born of the amplified dynamical Casimir effect field. Once local populations began to synchronize, the brain's natural attractor dynamics amplified these correlations into large-scale coherence. Oscillatory networks locked into phase, cross-regional rhythms synchronize, and the global dynamics stabilized into unified activity patterns. What began as a refined dynamical Casimir effect signal was now expressed as macroscopic neural coherence, the ordered large-scale oscillatory patterns associated with clarity, awareness, and integrated cognition. Frederick said that meditation increased coherency in the brain by reducing the internal fragmentation of attention and stabilizing the oscillatory patterns that underlie cognition. When the mind ceased its habitual oscillation between desires, memories, and anticipations, then neural activity shifted from a noisy, desynchronized state into one where large-scale networks fell into more harmonious rhythms. This coherence emerged because meditation attenuated the constant generation of new identifications. Those were rapid, unconscious micro-intentions that normally scattered neural firing across competing circuits. As the rate of such identifications decreased, the brain's intrinsic oscillations became more regular, allowing normally competing regions to resonate at shared frequencies. The result was a measurable rise in phase synchrony, improved signal-to-noise ratio, and more integrated dynamics. In effect, meditation did not add anything to the brain. It subtracted noise, fragmentation, and reactivity. What remained was a clearer, more unified field of neural activity whose coherence reflected a mind that was no longer driven by unconscious impulses but aligned within itself. Linus explained that the brain was a specialized, localized awareness amplification, awareness structuring, and awareness informational processing device. One could quantify awareness by adding the purity of the state mu equals det 2 gamma frac 1 2, where gamma was the detectable covariance matrix. Even with a pure mu, the information measures are geometry-dependent through the mode structure. The purity only ensured no classical ignorance existed, not that the subsystems were geometry invariant. Then awareness could be quantified by A equals mu. When quantum fluctuations interacted more intelligible with the medium, then mu went up. Globally, the vacuum state of the universe was pure, meaning the underlying field of reality was wholly self-consistent, unfragmented, and eternally coherent. Global awareness was total and undivided. It corresponded to a condition where the whole cosmos was a single self-knowing act of awareness. Locally, however, when one restricted the vacuum to a finite region, one must trace over the rest of the field, producing a mixed state within the region which was maximally impure. This was a direct consequence of the Riesch-Schleider theorem. The result was that the global pure vacuum now appeared as highly impure. Its coherence was obscured by the partiality of perspective. Therefore, locally, in a small region of the universe, the intrinsic awareness of the vacuum was almost negligible. The global vacuum was pure and coherent, but any restricted subregion, once traced over the rest of the cosmos, appeared as a highly mixed, impure state. Local awareness could only become significant if the vacuum fluctuations in that region were actively amplified by a dynamic boundary. For example, a rapidly oscillating mirror, vibrating microtubule, or other time-dependent structure. Such motion would generate a pure dynamical Casimir effect, converting latent vacuum potential into measurable excitations and effectively increasing local awareness. In other words, local consciousness required a mechanism to couple the latent universal awareness to a local subsystem, and the dynamical Casimir effect provided a natural physical realization of this amplification. Without an active boundary, local awareness was almost zero because the vacuum was highly mixed locally. A local dynamical Casimir effect could restore local purity if the system was sufficiently isolated and one were considering the entire set of modes that were coupled and excited by the boundary L, while ignoring the static entanglement of the vacuum with the rest of space. The covariance matrix gamma became pure within the subsystem, even though the global vacuum remained maximally entangled. Frederick postulated that emanation could be understood as the localization of a global, undivided source into progressively structured hypostases, rather than a fragmentation of the source itself. The source remained global and undivided, while the localization introduced limitation. The One, as the ultimate principle, was timeless, simple, and indivisible, containing no parts or extension. It was pure unity and global simplicity. Nous arose as the first localization of the One's simplicity, reflecting it into a structured intellect. The world soul was a further localization of Nous's global time, manifesting temporal order. While the world soul was coextensive with the universe in its temporal activity, it was not spatially extended, because extension belonged to the receiving matter, not to the world soul itself. As such, the material world localized the world soul's global space, creating a finite, restricted landscape. Therefore, the entire global spatial universe could be seen as the world soul, while local manifestations were the material world. Thus, each stage of emanation preserved the integrity of the source, while introducing local finitude and structure, allowing the global activity of the One to be progressively instantiated. William likened this idea to the philosophy of holism, which posited that the whole was more than its parts. With this philosophy, he could deduce that even though the local vacuum was not aware, that did not imply that the global vacuum was not aware. Frederick agreed and said that global awareness inherently included all local states without needing the local to be aware. Awareness was non-local and indivisible, and local lack of awareness did not prevent its inclusion in the global aware field. William likened the world soul to an ocean and the material world to a wave. He told them to imagine the universe's global vacuum as a boundless, continuous, and single ocean. This entire ocean represented the global awareness. Crucially, the ocean, as a singular, holistic entity, was the only domain where awareness truly resided. This awareness was non-local and indivisible. It was the unified state of the whole system, embodying the holistic principle that the whole was more than the sum of its parts. On the other hand, the local vacuum state was likened to a single ocean wave. A wave as merely a temporary, localized disturbance or configuration within the ocean. The wave, on its own, exhibited absolute lack of awareness. It was simply a manifestation of energy moving through the water that did not exhibit the same awareness as the ocean. However, he said, this local lack of awareness did not prevent its inclusion in the global awareness. Just as the wave was intrinsically composed of and supported by the ocean's water, the local state was inherently included in the whole. The ocean encompassed and defined the state of every individual local state without requiring the wave itself to be aware. The global unified state was the fundamental reality, and the local state was merely its temporary, non-aware geometric configuration. William thought that Frederick's presentation explained the theory of awareness as quantum fluctuations very well. He figured that quantum fluctuations in the material world had become so distorted by multiple layers of localization, but the monad penetrated everything globally as his shadow was cast over all of existence. The localization of fluctuations captured the essence of the One's being so that it could be locally amplified and give rise to awareness. Interestingly, Frederick said, the beginning of universe had the dynamical Casimir effect as the cause of the creation of all matter. In the beginning, the universe underwent an extremely rapid expansion driven by the inflation field. This expansion smoothed out the universe and left it nearly empty of conventional matter and radiation. When inflation ended, the field became unstable and began to oscillate and rapidly decay. This marked a sudden, non-adiabatic change in the effective background geometry. This rapid change in the scale factor AT acted like a massive dynamical Casimir effect across the entire universe. The energy stored in the oscillating inflation field was violently transferred to all other quantum fields, exciting their vacuum states and creating a vast thermal soup of all known particles. The electromagnetic field was conformal, meaning it was invariant under angle-preserving transformations, so expanding space did not amplify the electromagnetic vacuum state in a dynamical Casimir effect way. However, for non-conformal super-light fields like the gravitational field, then an expanding universe did produce a dynamical Casimir effect with large signal-to-thermal noise ratio when considering Hubble modes. These Hubble modes had wavelengths comparable to the Hubble radius, which was the radius of the observable universe. In the dynamical Casimir effect, a mode of a quantum field created particles when its frequency changed non-adiabatically. Expansion was slow compared to sub-Hubble modes' oscillation period. They evolved adiabatically and are practically not affected. Super-Hubble modes' physical wavelength stretched faster than causal processes can act, so their amplitude was practically constant, so the expansion did not create any particles for those modes either. Therefore, only modes with wavelength around the Hubble radius got created by an expanding universe. This cosmic dynamical Casimir effect was an effect throughout the whole universe, which could represent an undivided awareness across the global universe. This awareness spanned the whole universe, even outside the observable universe, and it was manifested as Hubble-scale particle modes. All Hubble-scale modes throughout the universe had to be considered for the state to be pure. If the cosmological principle turned out to be false, and the universe was not homogeneous at large scales, then Hubble-scale modes could couple with local modes, and so there would be information about local substance in the global modes. In this case, it could lead to a Hubble-scale awareness being aware of local events. This awareness could be viewed as the awareness of the world soul, and the world soul only manifested in the universe with gravitational effects, as was the field its awareness arose from through vacuum amplification. Furthermore, he said, inflation in the early universe was an attempt to reconcile the cosmological principle with the evolution of the universe. In inflation, the scale factor grew exponentially while the Hubble radius stayed constant. Dynamical Casimir effect-generated gravitons had their wavelengths scaled to many orders of magnitude larger than the Hubble radius. Depending on when during inflation these super-Hubble gravitons were created, they would eventually become Hubble-scale gravitons, since the Hubble radius grew more quickly than the scale factor after inflation. Therefore, since the rate of graviton creation during inflation was really large, then these particles would cause noise in the current-day dynamical Casimir effect spectrum. This noise would drown the Hubble-scale gravitons being created by expanding universe today, and it would effectively make the measured state impure, which would lead to no global awareness. However, if the cosmological principle was wrong, then inflation lost its purpose, and there would not have been any super-Hubble gravitons created during inflation. All generated particles would have remained sub-Hubble. Then the measured gravitons at Hubble scales would be pure, and there could be a global awareness. He added that discoveries of large structures such as the Hercules, Corona Borealis Great Wall, which was 10 billion light-years wide, and the GRB ring, which was 5.6 billion light-years wide, challenged the assumption that the universe became statistically homogeneous above 1 billion light-years. If the universe violated the cosmological principle on Hubble scales, then inflation, whose sole purpose was to enforce large-scale homogeneity, lost its explanatory power. Without inflation, there was no super-Hubble amplification of primordial gravitons, eliminating the enormous squeeze-state background that would otherwise drown the present-day gravitational dynamical Casimir signal. The Hubble-scale modes generated by today's expansion would therefore form a pure, coherent quantum state, capable of encoding global information and giving rise to a global awareness. If the cosmological principle failed, then the universe was inhomogeneous, so that stochastic mode coupling arose, which gave rise to perturbation of the gravity. This could be seen as the world soul's epistrophe mechanism, whereas diffusion in the electromagnetic potential was caused by the material world's mind. William argued that viewing the universe from with Hubble's scale would seem as though space was a grid of infinite points, which were not causally related, since at some point matter-space would expand very rapidly, creating an event horizon, isolating the space within. This non-causation between points made the definition of space meaningless, and the definition collapses since no point could receive energy from a neighboring point, and therefore space lost its potential for energy exchange from that scale. This corresponded to the idea that the world's soul was before space and existed purely in time. Frederick said that it could be that there was an even weaker force than gravity, but instead a temporal force that could create a temporal event horizon at even larger scales, thereby making each point in space temporally isolated from itself, thereby giving rise to the eternal nous. The totality of everything collapses into a single non-extended point, which would be the one. The Reversionists felt like they had enough discussion and wanted to return to the Guru's house. William told the people in the church that they should join them, as their chances of passing the trial would be better if they learned a cohesive framework from the Guru. The priest said that their faith was in God. He quoted Corinthians 5:7, "For we walk by faith, not by sight." He proclaimed that their lives were guided by trust in divine authority and not by what they perceived. He said that no framework but the scriptures could lead to salvation, so they would remain. The churchgoers agreed and also stayed behind as the Reversionists left. The Reversionists felt relieved in knowing the source of their awareness and coupling it with ultimate reality. They felt powerful as they were tapped into divine essence and had realized their true nature. What was left for them was to figure out the steps in order to pass the trial, since they were aware of the how of existence, but they were still unaware of the why. They marched determinedly towards the Guru's house in order to seek out more answers.